Welcome to GateX AML. We'll solve few problems on Maclaurin series and Taylor series. Okay. So f of x is cos 2x. You have to find the polynomial for up to 6, x power 6. So that means you have to derivate of 6 time derivatives you have to do. So the first f of 0 is equal to 1. F dash of 0 is equal to minus 2 sine 2x. This will be 0. F double dash of 0 equal to minus 4 cos 2x is equal to minus 4. F third derivative at 0 equal to minus 8 sin 2x plus 8 sin 2x, that is equal to 0. F fourth derivative is equal to 16 cos 2x, that is equal to 16. Fifth derivative is equal to 32 minus 32 sin 2x, this is 0. Sixth derivative at 0 is minus 4 sin 2x is equal to cos 2x is equal to minus 64. So now you put it in this Taylor series or Maclaurin series and you will get 1 minus 4x square by 2 factorial plus 16 to the power 4 divided by 4 factorial minus, these terms are 0, so I am just leaving those. This will be 64 x to the power 6 by 6 factorial. This is the answer. Next, find the Taylor series of f of x equal to e power minus x square about x equal to 0. Okay, so this becomes the Maclaurin series, x equal to 0 up to fourth term. So fourth term derivative what to do. So f of 0 is equal to 1, f dash of 0 equal to minus 2x into e power minus x square, this is 0. F double dash of 0 equal to, then again differentiate this, minus 2, keep it outside. This will be e power minus x square minus 4x square, okay, into e power minus x square. So we put 0 here, we will get it as minus 2. Similarly, f triple dash of 0. So we will get this as minus 2 common, minus 2 e power minus x square, then minus 4 2x e power minus x square minus 4x square into, so it will be 8x cube e power minus x square. So you put 0 here, this will be 0, will be 0 and this will be 0. Okay, so this will be again 0. So we calculate something like this. Then finally we will get it as f of x is equal to, so this first term, third term are 0. So 1 plus, so second, first term is 0, second term, I'll write second term directly, that is minus x square divided by 2 factorial, so 2x square, and then plus x power 4 by 2, if you simplify, then minus x power 6 by 6. So this will be 1 minus x square plus x power 4 by 2 up to 4 terms. Next, we'll take some limit problems. So they are given cos x minus e power minus x square by 2 divided by x power 4. You can apply L'Hopital's rule, but you have to differentiate it 4 times. So just you already know how to get this Maclaurin series for this, so because x is tending to 0, so a is 0 here. So if you evaluate, you will get cos x is equal to, so 1 minus x square by 2 plus x power 4 by 24. See, because the denominator is x power 4, I can expand till x power 4 only, it is sufficient. Similarly, minus e power minus x square by 2, previously just we found out, so 4 terms. So that will come out to be 1 minus x square by 2 plus x power 4 by 8. Now you just substitute here power 0, 1 minus x square by 2 plus x power 4 by 24 minus 1 minus x square by 2 plus x power 4 by 8 divided by x power 4. So this gets cancelled. So this is nothing but limit x power 0. So x power 4 divided by 24 minus x power 4 by 8 divided by x power 4. So I can cancel x power 4 and I will get it as minus 1 by 12. Okay. Next. So this is straightforward if this number was small. Okay. Now you convert this e power 2x. So e power 2x is simple to convert to Maclaurin series. So f of x for this will be given as so we go on derivating. So seventh derivative of this till the seventh derivative. So if you observe here, see, you can just use shortcuts. You need not solve everything. So this is a simple function. Every time I find it, so first let us find f of 0. This will be 1. Now f dash of 0 will be 2 e power 2x. So that will be 2 because it will never become 0. Now f double dash of 0 is equal to 4 into e power 2x. See, every time it is 1 to power 1 to power 2. So it for seventh derivative, what it will be this? This will be 2 power 7. Okay. 128 e power 2x. And this is how you can just approximate quickly. Now, this will be turned as e power 2x limit of x approaches. So what will be the seventh term? So seventh term, this will be equal to 128. So seventh term in your Maclaurin series will be what? So it is anyhow positive. So it will be 128 into x power 7 divided by 7 factorial, right? 7 factorial. So I can just write this 128 by 7 factorial. So I will just ignore this part because they are minimal compared to x power 7. So I will just write the major term approximation divided by x power 7. Is nothing but 128 divided by 7 factorial. So I think you'll get it as 808 by 315. Okay. Next. Log of cos x divided by x square. Okay. Now there are two functions here. One is log, another is cos x. And the highest term I have to approximate is x square. So first find cos x. Cos x you will get it as 1 minus x square by 2. Even if you apply L'Hopital's rule directly, it will be 1 by cos x, then again sin x, then tan x, then you differentiate, it goes on like that. So this term is small, you can apply directly L'Hopital's rule, but still it is not that easy. But if it is say x power 7, x power 6 and all, that will become different. This equation at the top, you go on differentiating this, it becomes very big. So it is better you apply the Taylor series. So for cos x it is like this. Now see, entire function you can take and then apply Taylor series, but it becomes very difficult. Again, you have to differentiate this, no? Ln cos x you have to differentiate. It becomes equivalent to your L'Hopital's rule. That is direct differentiation. So let us put this function inside this function. Okay, f of g of x, you will learn, right? That like that. So it is of the form what? Composition of the function f of g of x. This is what it is like this. So this is log function. This is cos x function. Okay. So cos x for two terms is like this. Then similarly log of, let us say, t. See, I cannot derivate log t because it is not differentiable at x equal to 0. Because 1 by t equal to 0 means 1 by infinity. So we cannot derive. So we know already, you can just approximate this. Ln 1 plus t I know. So ln 1 plus t I can find it as t minus t square by 2. Only two terms are sufficient for me because the denominator is x square. Now, so in this I have to put cos x. So let's assume this is the form I want to get. So ln cos x is what I need to get. But it is in the form ln 1 plus t. What would be t value in terms of cos x such that I will get this form? So instead of t, I can replace cos x here. So if you observe here, this will is if I put t equal to cos x minus 1, I put t equal to cos x minus 1. What is that I'll get? ln 1 plus cos x minus 1. So again I'll get back the same. So I can substitute t equal to cos x minus 1. So this is nothing but ln 1 plus cos x minus 1. Okay. So this is my t. This is 1 plus t. 1 plus t I already. Now you got t equal to cos x minus 1. Substitute it here. T minus t square by 2. That is ln of cos x is nothing but what? ln of 1 plus t. That is again t minus t square by 2. Now you substitute it here. So what is t? T is cos x minus 1. So cos x minus 1 minus t square by 2. What is t? Again cos x minus 1. That is cos x minus 1 whole square divided by 2. Now you substitute cos x is 1 minus x square by 2. That is 1 minus x square by 2 minus 1 minus of, again cos x is 1 minus x square by 2 minus 1 whole square divided by 2. This will be equal to minus x square by 2 minus of, this get cancelled, minus x to the power 4 divided by 8. Now this is ln cos x. What is the limit now? Limit x approaches 0. Okay. So x square minus x power 4 divided by 2 divided by 8 whole divided by x square. This x square is there, no? Now this will be, to solve this limit, this will be take out square common, limit x approach 0 minus x square minus 1 by 2 minus x square by 4, sorry 8 whole divided by x square. This gets cancelled, this plus here. Then we'll get it as, to put 0 here, get it as minus 1 by 2. This is the answer. So thanks for watching. We will solve few previous year gate questions in the next video on this optimization topic. Please like, subscribe and share.